Alright, let's look at the next 5. This one says Rhonda spun the spinner below 8 times. The spinner stopped on yellow 4 times. Which of the following is true? So if I look at this spinner and think about what it's saying that 4 out of 8 times it landed on yellow. That's 50% of the times that I spun this, it landed on yellow. But I see 1 out of 6 on the wheel are yellow. They're all equal parts. So when we actually did the experiment, this is the experiment, she spun the wheel 8 times and got yellow 4 times. That's the experiment. This experiment and this theoretical, these don't match. 1 out of 6 would be the theoretical probability. 1 divided by 6. That's 17%. That's the theoretical probability. 1 out of 6 of those spaces are yellow. So in theory we should only get yellow 17% of the time. But she got yellow 50% of the time. So her experimental was more than her theoretical. So I see that here. The experimental probability of spinning yellow is greater than the theoretical probability of spinning yellow. Number 7 says Norman spins the 2 spinners below. What's the probability that it'll land on 1 or 2? And red and yellow. Red or yellow. So this is a compound probability question because you're doing one thing and you're doing another thing. So 2 things in a row. Kind of like shooting free throws. So what I do is I find the probability of this, multiply it by the probability of that. So I'm trying to land on a 1 or 2 on here. So that's 2 out of 3. 2 out of 3 spaces are either a 1 or 2. And then red or yellow. Red, yellow. 2 out of the 4 spaces are red or yellow. So I take these probabilities, 2/3, and multiply them by one another, times 2/4. So 2 times 2 is 4. 3 times 4 is 12. Which equals 1/3, which is option C. Number 8, we have a list of ice cream flavors and a list of candy toppings. It says ice cream comes with a choice of 1 flavor and 1 candy topping. How many different combinations of ice cream flavors and candy toppings are possible? Well, you could make a tree diagram of these, but you could also just count how many of each are in each category. So I see 1, 2, 3 flavors, and 1, 2, 3, 4 toppings. Multiply those together. 3 times 4 equals 12, which is B. I encourage you to make a tree diagram here just as a good exercise. But like I said, the shortcut is just to multiply them together. Alright, number 9. The results of an experiment are in the table below. Which statement is true? So this says these are the results of 30 rolls. These are experimental results. This is an experiment. So if there are 6, so I want to think about the probability here in theory first, so we can compare. For each one of these, 1, 2, 3, 4, 5, each side of the dice, there's a 1 in 6 probability that you'll land on it. So 1 divided by 6 is 17%. And there are 30 rolls altogether. So you want to think about what is 17% of 30. 30. So if we're rolling 30 times, just like the problem before here, we're imagining picking these cards at 72 times. Here we're imagining rolling this dice 30 times. So we want to think about what is 17% of 30, and to find a percent of a number we multiply by the decimal. So 30 times 70%. 30 times 0.17, 17%. So we should expect to get each number about 5 times. each side of the dice, if we roll it 30 times, about 5 times, which makes sense because if we do 6 times 5 is 30. So there are 6 sides to the dice. So if we land on each one 5 times, that'll be 30 rolls. So if we look up here in the data, under the times rolled, we rolled a 1 4 times, a 2 5 times, rolled a 3 5 times, a 4 7 times, a 5 2 times, and a 6 7 times. So now we're comparing the theory with the experiment. So would we have expected to see more 5s? How many 5s did we see? We saw a 5 rolled 2 times. We would have expected more. That's right. We would have expected more 5s to have been rolled. We expected there to be 5. Each side we expect to be rolled 5 times. The 5 was only rolled 2 times. We would have expected fewer 2s. How many 2s? No, we saw 5 2s, so that's how many we expected. Expected fewer 3s. We saw 5 3s, so we wouldn't expect fewer. D, we would have expected more 4s. How many 4s were rolled? 7. That's actually more than we expected, so that one's not true. So our answer is A. We expected more 5s because only 2 were rolled, and we were predicting there to be 5 rolled. So the answer is A for 9. Last question. Heidi had 24 socks, 16 brown socks. Heidi had 24 white socks, 16 brown socks, 4 pink socks, 12 yellow socks, and 14 black socks. She picked one sock without looking. What's the probability that it will be pink? This is a simple probability problem, which means we're looking for desired outcome over total number of outcomes. So our desired outcome here is we're looking for pink. We're trying to figure out what the probability of selecting a pink sock is. So first we want to know what the desired outcome is. In other words, how many pink socks there are in her collection. So there are 4 pink socks. 4 pink socks. And how many total socks are there? So now we'll have to add up some numbers here. We have she has 24 white socks, 16 brown socks, 4 pink, 12 yellow, 14 black. So we have to do some addition to get our denominator here. So we'll add up 20, you might be able to do this in your head, 24 plus 16 plus 4 plus 12 plus 14, so that's 70. So she has 70 pairs of socks, or 70 socks. So that is 4 pink socks out of 70 total socks. So that should be our answer, 4 over 70. But I do not see that number over here because we need to simplify. So we're trying to think about what number goes into each, what number goes into the numerator and denominator. So we're thinking about our divisibility rules here. This is an even number, this is an even number. So let's try 2 first. So 4 divided by 2 is 2. 70 divided by 2 is 35. So we see 2/35 right here. So our answer is A. The probability that she'll select pink is 2 out of 35.